Okay. Hello, my name's Evan Simisak. This is a recording demo for Info 6019 Physics and Simulation Project 2, where the purpose of this program is to familiarize with physics simulations and rendering of 3D graphics by making a little firework project. So, main things that I added to the base code. So the C particle system was part of what was given to us. However, I don't know why. Something to do with my implementation, obviously. But no matter what I did, if I tried to make a firework class that inherited from C particle, I kept getting linker errors and constructor. I forget what the exact error code was, but it wouldn't work unless I made the objects as particles. So I added some stuff that could be generally used on particles, such as timers and a boolean to check if it's alive, and specifically for the firework part, a firework type and firework stage, so that we know what kind of firework is being launched and what stage the firework is in. And then public getters and setters to access it. So set time alive to 0 when the particle is made. Otherwise, basics, setters and getters, add to how long the particle's been alive, get it, return it, etc. Super basic, getter setters. I'll get to this when I explain the particles. And I added 2 modifications to random numbers. The first one is a random vector that is mostly upward, has a random x between -10 and 10, random z between -10 and 10, and a random y that is between 10 and 50. Normalize it, multiply it by the inputted length, return the vector that's mostly up. Just kind of took this from project 1. And then getRandomVec3 circle is a modification of getRandomVec3. GetRandomVec3 is one we talked about during class. It returns any angle within a sphere, or any vector within a sphere from the point of origin, rather. So the RandomVec3 circle is a modification of that to just get the top half of the semicircle. Otherwise, in main, here's our includes. For some reason, Visual Studio is designed to have an error on a comment. Go figure. On the side, I removed the particle force generators. I need to actually delete them. Might as well do them now, since I'm not using them. Definitions to set the screen width and height. Want it taller than wider, since we're trying to show off some fireworks. Camera stuff that I made and did for graphics. Get the center of the screen. Again, this is just kind of camera stuff. Set up the callbacks for the graphics stuff. Load models from file is how I add models to the VAO manager, and then these are all stuff for the fireworks. So add meshes, we'll add a new mesh every time a particle gets made. Add particles, makes a new particle depending on the kind of firework. And then launch a number of particles depending on the type and stage. Rather having these as a big if statement, I just did separate methods. So we're in our main, do the default GLFW stuff. Do I ever actually use axes? Can't say that I do. Probably can just delete that. I just use default 1 0 0 0 1 0 and 0 0 1. Since we're just assuming that y up is our up. Yeah, I'm not using that. I don't remember why I added it or what I was supposed to use it for. Anyways, GLFW stuff. Open the shaders. Do all that stuff. As well as a platform, I added some bunnies to provide context for when we're launching stuff. This is just some math to always face the camera towards the origin. And then we get into the main loop. Delta time is default stuff. Default GLFW stuff. Copied the FPS title stuff from the Simple Game app. I just thought it was kind of nice to be able to watch it. So this is where the main stuff of this project comes in. So the world time step, we use the cParticle world. Every time we make a particle, we add it to the world. And when we time step, we just go through every single particle and run its integration step. And then I may have skipped over that at the beginning. Yeah, here. So this vector of meshes is all the meshes that we want to draw in the scene. This string of model locations is the actual string name of where to find models when loading into the VAO. Particle world is the world that all the particles exist in, and this vector of particle pointers being used as fireworks keeps track of all the existing fireworks. So in each time step, we need to go through each firework, and because I have those 6 meshes for context, each vector after those, or each mesh after those in the vector, corresponds to an equivalent firework. And so we update its position based on the firework position. If the firework is no longer alive, we pull its type, stage, and position, remove it from the world, erase it from the vector, erase it from the meshes, decrease our index so that we don't skip anything. If it's a stage 1 firework, depending on its type, launch the next stage. And if it's a stage 2 firework, only on the 3rd type of firework, we launch a stage 3, which could easily implement more stage 3s. I just didn't. For time and brevity, this is no longer applicable. Anyways, yep. So then, after updating the meshes, and particles, go through all the meshes and draw them. Oh, this was just some testing stuff to make sure what I was doing would work. Draw the model name. Scene is drawn, present it. When we end, we destroy the window. So this load models from file. From the solution directory, common assets models. There's a models to load txt. So solution directory, common assets, models to load. Just have the two models. I'm just using the bunny and the floor. But if you want to change the bunny, my shader program takes the vector positions and vector normal. So if I open this in Notepad, vector XYZ and normal XYZ is what we need in our apply files to load the model. This just goes through and adds them to the VAO manager. Key callback, basic camera controls. A lot of this stuff I figured out from a Learn OpenGL tutorial here. In particular, the mouse callback, so that we have a free-flying camera that you can look around with. This was fun math to learn about. But anyways, so WASD to move the camera, Q and E to move the camera up and down. And for this project, when you press 1, we add a type 1 stage 1 particle with a 0 position. If you press 2, add a type 2 stage 1, and if you press 3, add type 3 stage 1. So here, for stage 2 and 3, we need the position of the old vector. So we make a new particle pointer, set its scale and color by default. If we're a type 1 stage 1, which is activated by pressing the 1 key, we set the position to a random position here. Why am I not just doing this here? That's a good question. Huh. Why did I not think of that earlier? Anyways, I'll update those as we go. Anyways, I kept the mass at 1 just so that I could play with acceleration and damping on the different fireworks. But yeah, each stage 1 is going to start at a random position just above y equals 0, between -5 and 5 in the x and z. So for stage 1, I set a velocity of 10 up, an acceleration of -2.5 down, set the type and stage, set it's alive, set how long it'll last 5 seconds, make the bunny big, and set the color of the bunny. For type 1 stage 2, set it at the previous position, set its velocity to the sphere with magnitude 2, give it a 0 acceleration so it kind of just hangs and slowly moves wherever, in whatever direction. Type 1 stage 2, it's alive for 3 seconds. Make it half as big as the stage 1. And let's just give them some random colors for fun. And an error check. That would break out of the function if it's a bad input. So for a type 2 stage 1, again, it's always going to start here. Okay. Set its velocity to a random upward vector with magnitude 15. Set its acceleration to negative 3.2x, negative 3.2y, 3.2f, x, z. Change its damping just to play around with it. Type 2 stage 1, it's alive, 4 seconds, make it nice and big. Let's make it a little smaller for fun. It's alive, it'll be alive for 4 seconds. And set its color for stage 2 type 2. Set its velocity, same thing, just random upwards, but we double and reverse the acceleration, same damping, type 2 stage 2 for 2 seconds, different scale, random colors again, because why not? Fireworks are supposed to be colorful. And for type 3, no error, good. I'll keep one of these just in case. So for stage 3, set the velocity to positive 6x, positive 6z with a random y between 20 and 50. Set the acceleration to this, but it's not going to be that exactly. Set the damping to 0.15. Again, just kind of playing with it, finding stuff that worked and that looked good. Type 3 stage 1 is alive, true. Time to die 5 seconds. And I'll make this one a little bigger, actually. Set its color. But I actually changed that a little bit in the particle integrate, which this should just be in the firework integrate, but whatever. If we're type 3 stage 1, we're going to do a little bit of fun math to have a nice spiral upwards. Taking the cross product of the velocity and the negative down so that it spirals inwards rather than outwards. Normalize it, and then set its magnitude to the square of the velocity divided by 5. I found that to work pretty nice. And then set the y to negative so that it slows down. And then the rest of the integration stays the same. So for firework 3 stage 2, initialize its position. And then this is where I use this upward semicircle, which I use for both stage 2 and stage 3 with different magnitudes. Kind of give it a nice bouncing fountain effect. And again, just got these don't have the spiral acceleration, just have downward gravity, playing with the damping, time, scale. Let's make this 3, this 6. Why not? I know it's not the cleanest, I know it's I'm annoyed that I couldn't get the firework class to inherit properly, but we make do with what we make do. So after creating it, again, error check if whatever was inputted to the function isn't actually valid. Just break out. We don't want to add it to the world or the vector. And then after, we make a new mesh to represent it. Every single one is going to be the bunny at the location of the bunny. So if you're going to replace the bunny model, make sure it is the first model in the text file. The position, which is passed through from here, which is wherever the particle is, so that it always starts in the same position, and then the scale and color are set depending on the particle. And then the wireframe and override color are both true because that's just how I have the meshes made, and push the mesh onto the vector. So these are the functions that are actually called when you press 1, 2, or 3, and then again in that for loop when a particle dies, if it's stage 1 or stage 2, to launch the next stage. Passing the position so that we can pass the position into add particles. And all of these I decided let's just make the explosions fun with random numbers. So for type 1 stage 2, it'll have a random number of second stage particles between 10 and 100, and then it just goes through and adds them all. For type 2 stage 2, it's a random number of particles between 5 and 20. For type 3 stage 2, it's a random number between 20 and 40. And for type 3 stage 3, it's a random number between 10 and 20. Because if we got 40 and 20, we would have 800 particles on the screen at about the same time. Debug x64 and release x64 work. I do not have the CMake stuff or GLFW in Windows in 32-bit. So here, these are just some checks. The bunny and floor model get loaded okay. So, as I said, WASD to move the camera, move the mouse to actually change what the camera is looking at, E to go up, Q to go down. And here I have that floor model and the bunnies on the corners, just to have some context for where the models are. We haven't learned how to do skyboxes and textures yet, so just a black background. So if I back up a bit, or even just close it and go back to the default position, I think I need to move the camera in just a little bit, but pressing 1 launches a firework straight up. It's the most basic one, falls a little bit, and then explodes into a sphere of bunnies. And for the harder mark, Crazy Fireworks Show, I can press 1 as many times as I want, and it just launches new bunnies. If I press 2, color's green, just so that there's a visual difference. But each type 2 kind of gets launched to the right and away, and then each stage 2 gets launched back. Because of the acceleration and how long it's alive, they kind of always end up like that. So it's kind of a type 2 is kind of a windy, sort of like there's wind and it blows the firework around. And type 3, there's a little spiral and then it slows down, falls a little bit, explodes, and then each one explodes again. And again, I can just keep pressing the buttons and they just keep launching, and we're going to watch the frame rate tank. Because of how many models are on the screen, and it'll catch up after a little bit. possibly crash. Nope, there they go. The third stage potentially adds a lot of fireworks, so they can really slow down the system. But yeah, I think that's everything. 5 marks per type of unique firework. Harder Mark, Crazy Fireworks Show. Harder Mark 2, third stage. One type of firework has that. So, yep. At the end, remove all the object from the physics world, and because of how I'm doing it, remove all of the object from remove the meshes. Okay, I just realized I didn't write the README yet, so I'm going to do that. Remove all the unnecessary files and zip it up. Thanks for watching.